So just in a nutshell, if you want a CGH, what do you do? So the first thing is you have to start out with defining what it is that you want to measure. The most common thing is to measure surfaces: convex, concave, aspheric, freeform aspheric, bare glass, coated, metal. We also measure lenses, light that goes through a lens. We can provide correction for that. And as I said, the accuracy is around 1/100th of a wave is a standard. Some limitations, there's a primary limitation for convex optics because the wavefront has to fit the shape of the optic. If it's convex, that wavefront at the CGH has to be bigger than the measurement region. And the typical, or our standard CGH size is 6 inches square. And so if you have a convex optic that's bigger than that, usually with a single CGH, we can only measure a portion of it at a time. And there are some very difficult surfaces that have high aspheric slopes or discontinuities, and those can create some complexities. So the key thing for today's talk is really alignment. And usually the hardest part is not actually designing or doing the alignment, it's getting the alignment requirements clear. And so this comes from you. If you want to make a measurement and you want it to be aligned to what? You need to define clearly what the datum features are that you need the optical alignment to be positioned, that you need the optics aligned to. If those are defined, I'll show you we have a number of tricks in our bag to be able to basically get whatever alignment you want, as long as these requirements are defined. So some common ones for axisymmetric parts is the outer cylinder. Lots of times there's an edge flat on there for a circular part that's used for clocking for a freeform A-sphere. Diamond turned optics have all kinds of flexibility, things that could be manufactured into the optic, into the substrate. The back plane is a common one. Sometimes precision pinholes that are used for assembly, we can use those to pick up in the optical test. It's helpful if you specify what your interferometer is, because we'll design our CGH to that. And so that makes it pretty easy for you. And then you have to consider schedule requirements. These CGHs are custom elements that need to be designed and manufactured. And so they take about a month. We can turn them around in 2 weeks if we set things aside and go as fast as we can. But you need to consider the schedule.